Okay, today we're going to talk about graph theory, and we're going to start with a puzzle that you might have seen before. It's called Connect the Dots. I have a diagram where I have these dots. I have 6 dots, and I have the lines connecting the dots. And the way the puzzle works is you have to draw this figure in one continuous motion, connecting dots, going from one dot to another. So let me show you how I can do it. I can go like this. I can go like here, 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 here. And I've drawn that figure in one continuous motion. Also, I forgot to mention, you have to do it without retracing, without going over the same line twice. Now, in this one, I started and I finished at the same spot, but that's not going to be part of this puzzle. It's okay even if you start and finish at a different spot. Now, let me try it a slightly different way. I could go like this. Now, I'm stuck. I can't finish the rest of the drawing without picking my marker off the board. So this problem is solvable, but you're not going to solve it every time if you don't take the right approach. Okay? It wasn't too hard. The first time I did it, I got it. You try it. You'll probably get it. If you don't get it on your first try, you'll probably get it on your second try. Now, let's try something that's actually a little bit harder. I'll do it like this. I'll put the dots here. We need to connect the dots, and it looks like this. So this looks a lot like the other one, only it's a little bit different. Now let me try this one. I'll try it like this. I did it. Now you can see, when I get to these spots, I don't quite connect it because I want you to be able to see the full path of what I did. If I drew it exactly like that, you wouldn't be able to tell what my path was. But when I draw it like this, you can actually see the whole path from beginning to end. I start in one spot and I finish in another. I said earlier that that was okay. Now, let me try it another way. I'll try it like this. Okay. Now I'm stuck. I can't do the last one because I'm stuck right here. And I can't get any further. So, this one, you can do it, but you're not going to get it every time. After you try it a few times, you'll probably get an answer. It's not as easy as the first one. It's a little bit harder because the first one, usually you'll get it. This one, you don't get it all the time, or even usually. Let me try one more. This one is actually harder. I'll draw it like this. Okay, it's a lot like the other ones. It's actually simplified. I threw away a lot of stuff. But it turns out, it doesn't make it easier. It actually makes it harder. Let me try it this way. I'll just try it. You never lose by trying. You just have to try, see what you get. Okay, that's as far as I could get. I couldn't get that extra one on there. Let me try it a different way. Okay, now I'm stuck. Uh, this one, it's really hard because nobody's figured out a way how to do this. This one actually, we now think is impossible because of the work of this guy Euler. He showed that certain problems are impossible to get, and the problem that he was working on wasn't so much a puzzle with dots and lines. It was a problem called the bridges of Konigsberg. Now let me show you. Here's a picture of the bridges of Konigsberg. Konigsberg was a town where there were two islands in a river, and there were 7 bridges going across it. And there was a puzzle. Is it possible to start in one spot, go across all 7 bridges without going over any bridge twice in one continuous path? You don't have to finish at the same place you started, but you just have to try to go across all the bridges in one complete path. Now, nobody ever figured out how to do it, and somebody wrote a letter to this guy Euler, and they asked Euler if he could solve the problem. Well, Euler did solve the problem, but he didn't solve it by actually doing it. He solved it by showing that it was impossible. And it was a lot like that last one I showed you. So, now, I'm going to draw a diagram here where I'm going to draw it like the stick diagram. This will be one of the bridges. This will be another bridge. That'll be like a dot. This will be another bridge here, and another bridge here. This is the bridge here. This is a bridge here, and a bridge here. Now, Euler never drew a diagram like this. He solved the problem without drawing a diagram like this. He drew a diagram that was more like this. But he did solve the problem using the same ideas. And since I can't draw this whole thing like this, this is a lot easier to draw it. And I can give you exactly what Euler's argument was about why it was impossible using this diagram. A lot easier than that other one. Now, first, I suppose, I told you it was impossible, but let me just try it anyway and see how far I can get. Okay, I got that far. I couldn't get the last one. Now, Euler looked at this problem in a slightly different way. He said he was using it without math at all, using just what he called logic. And back then, they didn't consider logic and math to be the same. But nowadays, we consider math and logic to really be the same subject. Now, what Euler said was this. He said, look, at this spot on the diagram, there are 3 bridges coming in and out of this spot. And on this spot on the diagram, there are 3 bridges coming in and out of the spot. And on this point in the diagram, there are also 3 bridges coming in and out of this spot. And Euler looked at it this way. He said, you have to start at one of the dots, because you have to start somewhere in the town. You then have to cross the various bridges and try to finish, having gone over each bridge once. Now, Euler said that some of these spots you're going to start at. Another spot you might finish at. Some of the spots you simply have to pass through on your journey. You're not going to start there, and you're not going to stop there. Now, let's take this one here. If this was going to be somewhere in the middle of your journey, you weren't going to start there, and you weren't going to stop there. It was just going to be in the middle. Well, eventually you're going to have to come into it on a certain bridge. Then you're going to have to leave it, coming out on a bridge. That leaves in your path, you've already crossed these 2 bridges. The only way you could possibly cross this last bridge is to coming in. But if you did that, you would have to finish at this bridge because you've already used up all the bridges. So any dot that's got 3 lines coming into it, you couldn't possibly have that in the middle of your diagram, of your complete diagram that you draw without taking your pencil off the paper. It has to be at the end. Or it could possibly be at the beginning. So for example, if you started at this, you could go out. Later you could come back in, and then you could go back out later. It's okay if you start here, or a spot like this you could finish at, because this also has 3, or this one has 3. But the problem with this is, it's got 3 of them. They each have 3 bridges. Now, you could start at one and finish at the other maybe, but you're going to have to, one of them can't be at the beginning or the end. It's going to have to, you're going to have to be one that you pass through. Euler realized that in this problem, you couldn't possibly do this in one trip, because you might start here and finish there, but you couldn't possibly go through this one with only going over each bridge once. And that's because that it had 3 going into it. And it's one of these bridges actually has 5 of them. But Euler saw that 5 is really the same as 3, because if you started here, you could go out, eventually you'd have to come back, then you'd have to come out again, then you'd have to come back again, and then you'd have to come out again. So you could start here, but you couldn't pass through here. Like if you were going to pass through this one particular spot, and if it wasn't going to be at the beginning or it wasn't going to be at the end, but you're going to pass through. So you weren't starting there. So first you'd come in for the first time in one, and then you'd have to come out. Now it doesn't really matter which one you come out. I'm only showing you to try to keep track of the total number. You'd come out one, you'd have to eventually come back in, you'd have to eventually go back out, eventually you'd have to come back in. Now the problem is, when you came back in for the last time, you can't possibly get out without retracing one of your steps. So this couldn't possibly be in the middle of your path. It has to be at the end. Or the other possibility would be at the beginning, like I said before. It turns out in this diagram, there's an odd number. There's 3 connections here, 3 bridges here, 3 bridges here, and 5 bridges here. And this is terrible, because if you were to try to do a complete path, you'd have to start or finish at each one of these, and you can only start and finish at 2 of them out of the 4, so it's really totally impossible. And Euler realized that, and that was back like in 1700s or whatever. Nobody else had figured that out before him. It was just using a little piece of logic. And using that same rule, you can decide all of those other problems that we worked on. Like, remember this problem? I showed you this problem. Well, let's take another look at this problem. Okay? Let me put the dots on there. See that spot in the middle? Those are just crossing over. You can't go in the middle and then come out another one. Those are just bridges that cross from this spot to this spot. Now what I told you is, if you look at each one of these, you'll see that there are 3 bridges here, 3 here, 1, 2, 3, 4, 4 here, and then 4 here. And then this one, that counts like 2 because it's got 2 bridges. Now, this is an odd number, and this is an odd number. But as long as you start on one of these and finish on the other one, it's going to be okay. Because you don't have to retrace any of your steps. And that's just what I told you before. If you start at one of these ones on the lower side, like here, and then go up, 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 up. Well, let's go like here, 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 here. I started over here, and I finished over here. And I didn't have to retrace any. But if I start here, that means there are 2 of them that are going to have 3. So if I start here, for example, up in that corner, and then I try going like this, I can go like this. But what you'll notice is, when I get to that one that has 3, when I come into that, on the second time I come into it, I'm going to be stuck. Because the first time I came in, I could go out. But the second time I come in, I'm not going to be able to get out. So I'm not going to be able to finish the diagram, because I had 2 of them that had 3 connections to it. And that means I'm going to get stuck at one of them. So Euler said, this is a bad place to start. Don't start at the 4. If you have 2 odd ones, then always start on one of the odd ones. If you have more than 2 odd ones, then you're in trouble. It's impossible because you can't start and finish at that. And then, well, that should help you a lot in working on these puzzles. So I'll talk to you later. Okay, bye.